Hello class, welcome to Algebra Lesson 1-3, which is all about solving equations with a variable on both sides. By the end of this lesson, you should be able to write and solve linear equations with a variable on both sides to solve problems. Let's jump right into solving some equations. So yesterday we practiced where we had a variable on one side of the equal sign, but today we're going to step it up in level of difficulty and we're going to have variables on both sides of the equation, hence the name of the lesson. But if you look at this first example, you'll see we have 3x minus 10 plus 4x. I have two different x's on that same side. So in this lesson, we're going to practice combining like terms too before we start solving, okay? So we have 3x minus 10 plus 4x equals 2 times the quantity of x minus 4 plus 9. So I'm going to start by simplifying each side of the equal sign. So on the left side, I'm going to combine that 3x and 4x, turn that to 7x minus 10 equals. And then I want to get rid of that parentheses, so I'm going to start by distributing the 2 on that side of the equal sign. I'm left with 2x minus 8 plus 9, but I can still simplify that right side of the equal sign because I have an 8 and a 9 that can be combined, so that's going to become plus 1. Now that everything's simplified on both sides of the equal sign, I can start moving things from one side to the other, so I'm going to tee it up. And I'm going to start by moving my variable. That's my own personal preference. Technically, you can start by moving the regular numbers without the variables first. I like to get my variables on one side of the equal sign to begin. So I'm going to subtract 2x from both sides. If you chose to move the 7x, that's fine. You would end up at the same answer ultimately if you do everything correctly. But I like to move the smaller number. Then, once I have the variable on one side, I'm going to move the regular number, so the 10, over to the other side. So I'm left with 5x equals 11. And then when I tee it up again, I'm going to divide both sides by 5. And I have x equals, I wrote the wrong number. 10 plus 1 is not 10. It is indeed 11. So 11 divided by 5, I'm just going to leave that as the fraction 11 fifths. But if you changed it to 2 point, that would be 2. That is okay as well. Or if you said 2 and 1/5, these are all the same thing to me. Typically, I prefer that you leave things as fractions. As we move forward in algebra, you'll see why. And as we move forward in geometry next year, you will see why I tend to do that. But for now, you can choose what method you prefer unless I explicitly state it in the instructions. Jumping into the second part of this example, let's start by distributing and getting rid of those parentheses. So I have 1/2 n minus 2 minus 7 equals negative 2n plus 6. I can still simplify on the left side of that equal sign. So I have 1/2 minus 1/2 n, don't drop your variable, equals negative 2n plus 6. And when I do that, if I add 2n to both sides in order to get the variable on one side of the equal sign, I have 2.5 n. Wow, my writing is terrible today, guys. I'm sorry. 2.5 n minus 9 equals 6. Then from there, I'm going to move that 9 over. And I have 2.5 n equals 15. Then if I divide both sides by 2.5, maybe at this point you've switched to a decimal just because it's easier to type in on a calculator, you get n equals 6. Now if you ever get an answer that you're unsure of, is this right? Remember, what you can always do is take the answer you get, plug it back into the original equation you got, and see if it's true. Like, so if I plug a 6 in to this equation up here, do I get the same thing on the both sides of the equal sign? If I do, I know my answer is correct. If I don't, chances are there's a mistake somewhere. All right, question number 1. This is for you to solve. Good luck. All right, if you did this problem correctly, hopefully you ended up at D equals negative 3.4. If you have questions about that or anything else with example 1 or question 1, please be sure to reach out for some help, and I'm more than happy to assist you. Jumping into example 2, understand equations with infinitely many or no solutions. Okay, so if we look at the first one over on the left, if we solve this, there's nothing to simplify on the left side of the equation, so I'm just going to carry that down as is. The second part, I'm going to distribute that 2. And so now I have 4x plus 6 equals 4x plus 6. Now, if you're someone that rushes through your work, you might just keep going from there and subtract 4x from both sides. Or if you're someone that pays attention as you go through this, you might notice you have the same thing on the left and the right side of the equal sign. Everything's identical. Whenever this happens, this is called infinitely many solutions. Or you can say all real numbers. It doesn't matter what number you plug into this equation, you get the same thing, right? So if I plugged in a 5 to both sides, I would get 26 equals 26. If I plug in a 0 on both sides, I get a 6 equals 6. No matter what number you plug in, you're going to end up with the same thing on both sides. That's why it's called infinitely many solutions. However, if you're not someone that pauses and looks at their work each step, then chances are you started subtracting other things. So you said minus 4x, and hopefully at this point you saw something a little fishy and you got 6 equals 6. If you ever end up with something equals itself, that is infinitely many solutions. Now let's look at the next example. We have 6x minus 5 equals 2 times the quantity of 3x plus 4. I'm going to start by distributing that. So I have 6x plus 8 on this side, and I have 6x minus 5. Now if you look at this, I have 6x minus 5 equals 6x plus 8. I noticed that the coefficient with the x, so remember coefficients, whatever numbers with your variable, our coefficients are the same on both sides. They're both 6, okay? But the numbers that are constants without variables are different. This is another special instance. It's no longer going to be infinitely many solutions or all real numbers. This is what you call no solution. Or, if you would like to use a symbol for it, you can do a circle with a line through it, just like that. That is the symbol for no solution. It's actually called null set, N-U-L-L, set. I will accept both answers. So if you're, again, someone that moves quickly through your work and you didn't notice that you had the same number with your x on both sides and different numbers, then chances are you said minus 6x minus 6x, so you had negative 5 equals 8. Hopefully at this point you got a little alarmed. You said negative 5 never equals negative 8, and that should be what directs you to thinking this is no solution. All right, it is your turn. We'll try this problem, see if it's infinitely many solutions or no solution. Good luck. Hopefully for this problem you ended up at 64 equals 96, or you spotted the pattern right before you got to that step. And you said that that is never true, therefore this is a no solution kind of situation. All right, example 3, let's use these equations in real world examples. So, Cameron pays 95 cents per song with his current music service. A new music download service charges 89 cents per song with a $12 joining fee. Should Cameron switch to the new service? So we know Cameron pays 95 cents per song, right? So I'm going to represent that with 95 times x because I don't know how many songs he has. And then if he were to switch to the other service, he would do 89 cents times however many songs he purchases, plus no matter what, he has to pay that $12 joining fee. So let's figure out at what point does it make sense for Cameron to switch music services. So what we're going to do is we're going to set those two equations, or those two expressions equal to each other, and we're going to solve. So if I subtract subtract, I started writing divide, my apologies. If we subtract 89 cents from both sides, we end up with 0.06x equals 12. And then from there, if we divide both sides by 6 cents, we find out that at 200 songs, the plans are equal. So that means if Cameron buys fewer or less than $200 songs, it doesn't make sense to switch. He should stay with his current music service. But if Cameron decides he wants to download more than 200 songs, it would be cheaper in the long run to switch to this new service. Okay, so that's how you set up an equation like this and you solve it. Words are tough, sorry kids. Question 3, you're going to do something similar, okay? Cameron's friend tells him of another service that has a $15 joining fee, but charges 80 cents per song. At what number of songs does this new service become a less expensive option than Cameron's current service? So remember, Cameron's current service is 95 cents per song. Go ahead and try to solve this problem. Good luck. Hopefully your equation that you set up looks something like what I have up here on the board. If you have questions on how I got that, please be sure to reach out for some help. But then once you finish solving that equation, you should have ended up at 100 songs. So that's when the old plan equals the same as the new plan. So if Cameron plans on purchasing more than 100 songs, he should switch to the same service that his friend is using. If you have questions about that, do not hesitate to reach out for help. I'm more than happy to assist you. So our concept summary for lesson 1-3, we have the words and we're converting them to equations. And then remember how to tell if there are infinitely many solutions. If there are infinitely many solutions, I forgot to mention this earlier, it's called an identity. It means no matter what number you plug in, it keeps its identity, right? It's going to stay the same. Then, if you have something that doesn't work out, that is a no solution. Again, if you have any questions on anything from this video, please reach out for help. I'm more than happy to assist you. Have a great day.